Bismillah ar-Rahman ar-Rahim. Our today's topic is machine translation. Uh, Machine translation is a subfield of computational linguistics which investigates the use of software to translate text or speech from one language to another. So basically, machine translation is a process in which software is used to translate text or speech from one language to another language. On a basic level, machine translation performs a simple substitution of words in one language for words in another. Basically, machine translation just substitutes words of one language with the words of another language, but that alone cannot produce a good translation of text. It's quite obvious. Because recognition of whole phrases and their closest counterparts means the context of the phrases and words in the target language is required. Solving this problem with corpus statistical and neural techniques is a rapidly growing field that is leading to better translations, handling differences in linguistic typology, translation of idioms, and the isolation of anomalies. So with the help of corpus statistical and neural techniques, so the quality of translation has been improved. The software that are used for translation, they often have the option of customization by domain or profession, such as weather reports. You can choose the translation. You can give the command of translation that you are translating the text relevant to certain domain or profession, like weather reports, and this option definitely it improves the output or the translated text, because in this process the allowable substitutions of lexes of vocabulary is limited to that specific domain or profession. And this technique is particularly effective in domains where formal or formulaic or fixed language is used. So this technique is used and where fixed language is used, for like the government and legal documents, the language is fixed and it produces a usable output then as compared to the text of conversation or less standardized text. Apart from the domain option of softwares, and the improved output quality of machine translation can also be achieved by human intervention. For example, some systems are able to translate more accurately if the user has unambiguously identified which words in the text are proper names. If the translator fully recognizes which words are proper names, and of course the proper names are usually most often not translated, so this way also the human intervention can improve the translation text. With the assistance of these techniques, machine translation has proven useful as a tool to assist human translators, and in a very limited number of cases can produce output that can be used as it is. For example, weather reports. With the assistance of these techniques that we have mentioned here, two techniques actually, by limiting the translation process by domain or profession and human intervention. So these techniques can help producing translation that can be used as it is. For example, translation of weather reports. The progress and potential of machine translation have been debated much through its history, and since 1950s a number of scholars have questioned the possibility of achieving fully automatic machine translation of high quality. And first and most notably, this question was raised by Yehoshua Bar Hillel. And some critics claim that there are in principle obstacles to automating the translation process. So the question is, and whether is it possible to achieve a fully automatic machine translation that can be used as it is or not. And some scholars have questioned this, and some critics, they claim that there are some practical problems in this way of automating the translation process, and I do agree with these critics. Okay, here we have the translation process, human translation process actually. The human translation process may be described in two steps. Number one, decoding the meaning of the source text. First of all, you have to, as a translator, you have to decode the meaning of the source text. If you are translating Urdu text into English, so first of all, as a translator, you have to understand the Urdu text with this, to its full depth. And second step, so encoding this meaning, so then you put this into codes again. First you decode the meaning and then you re-encode this meaning in the target language. So it's so simple, it looks very simple, but simple procedure. You decode the source text and then re-encode that meaning in the target text, but this is not so simple. So there, behind this simple procedure, so there is a complex cognitive operation. How? To decode the meaning of source text in its entirety. So to decode, we feel that we understand the text and we understand our mother tongue or first language in its depth, but to decode the meaning of the source text in its entirety, the translator must interpret and analyze all the features of the text. All the features of the text, a process that requires in-depth knowledge of the grammar, semantics, syntax, idioms of the source language, as well as the culture of its speakers. So all these things should be considered when we decode, when we try to understand the meaning of the source text. And the same thing is needed to re-encode the meaning in the target language. Therein lies the challenge in machine translation. So that was the process of human translator, but Here the problem challenges for the machine translation, the how to program a computer that will understand a text as a person does. I mean, how can we make it? This is a challenge. How can we make a computer understand the text as a human does? And that will create a new text in the target language uh, that sounds as if it has been written by a person. So this is a challenge, how to program a computer who understands the source text and then create a new text in the target language that is like or similar as if it has been written by a person. In its most general application, this is beyond current technology. So far we have not reached up to that point, though it works much faster. No automated translation program or procedure with no human participation can produce output even close to the quality a human translator can produce. So here the machine translation process, it works very fast, I mean much faster than the human being do, but no machine translation program or procedure without human participation can produce the output even close to the quality a human translator can produce. So with the human participation we can produce better translations to some extent and faster as well, but without human participation the output cannot be achieved even close to the human translators. What it can do, however, is provide a general, though imperfect, approximation of the original text, getting the gist of it, a process called gisting. I mean, we cannot get a translation equal to human translators, but through machine translation we can just get a gist of meaning of the source text in the target text. This is sufficient for many purposes. I mean, this is not unimportant, but it can satisfy many purposes, including making best use of the finite and expensive time of human translator, reserved for those cases in which total accuracy is essential. I mean, translators don't have to spend much time for things where gisting of the source text is enough, and they can spare their time for the cases for the translations in which total accuracy is required or important. Different approaches we will see here that are used in machine translation. Machine translation can use a method based on linguistic rules. That means that words will be translated in a linguistic way, how the most suitable words of the target language will replace the ones in the source language. So the suitable words according to the oral the speaking practices of that language. To translate between closely related languages, the technique referred to as rule-based machine translation may be used. So the rule-based machine translation is a technique that is used to translate between closely related languages. So let's see this first. The rule-based machine translation paradigm includes transfer-based machine translation, number 2 interlingual machine translation, and number 3 dictionary-based machine translation. So this type of translation, the rule-based machine translation, so is used mostly in the creation of dictionaries and grammar programs. Unlike other methods, rule-based machine translation involves more information about the linguistics of the source and the target language. So it involves more information, linguistic information about both the source and the target languages. So using the morphological and syntactic rules and semantic analysis of both languages. The basic approach involves linking the structure of the input sentence with the structure of the output sentence. How? I mean, it's using the structure of input sentence and the structure of output sentence is linked using a parser and an analyzer for the source language, a generator for the target language, and a transfer lexicon for the actual translation. RBTM's biggest downfall is that everything must be made explicit. For example, the spelling variations and errors in the input, possible errors in the input must be made part of the source language analyzer in order to cope with it. And lexical selection rules must be written for all instances of ambiguity. I mean, in case of ambiguity, the lexical selection, how to select different lexes, different vocabulary items. So rules must be written for all possible instances of cases of ambiguity. And adapting to new domains in itself is not that hard, because I mean, if you move from one domain, from weather reports to health department or to education department, I mean, translation of different profession about different professions, it's not that hard because the grammar is the same across domains, and the domain specific adjustment is limited to lexical selection adjustment. Transfer based machine translation is similar to interlingual machine translation in that it creates a translation from an intermediate representation that simulates the meaning of the original sentence. Unlike interlingual machine translation, it depends partially on the language pair involved in the translation. Interlingual machine translation is one instance of rule-based machine translation approaches. In this approach, the source language, that is the text to be translated, is transformed into an interlingual language, that is language neutral representation that is independent of any language. The target language is then generated out of a interlingua. And first, the source language is represented into a language neutral, and then from that language neutral the translation is generated. Google Translate uses English internally as an interlingua for some language pairs such as Chinese and Japanese, and more generally those with higher quality neural network translators with English, but not between each other. One of the major advantages of this system is that the interlingua becomes more valuable as the number of target languages it can be turned into increases. However, the only interlingual machine translation system that has been made operational at the commercial level is the Kant system, which is designed to translate Caterpillar Technical English and into other languages. Dictionary based machine translation Machine translation can use a method based on dictionary entries, which means that words will be translated as a dictionary does, word by word, usually without much correlation of meaning between them. And dictionary lookups may be done with or without morphological analysis in this method. While this approach to machine translation is probably the least sophisticated, it's very simple, it's the simplest technique. Dictionary based machine translation is ideally suitable. This technique is ideally suitable for the translation of long lists of phrases on the substantial, means not a full sentence, on substantial level. For example, inventories or simple catalogs of products and services. It can also be used to expedite manual translation if the person carrying it out is fluent in both languages and therefore capable of correcting syntax and grammar. Statistical machine translation. Statistical machine translation tries to generate translations using statistical methods based on bilingual text corpora. For example, the Canadian Hansard corpus, the English-French record of Canadian Parliament and Europarl, the record of the European Parliament. Where such corpora are available, good results can be achieved translating similar texts, but such corpora are still rare for many language pairs. The first statistical machine translation software was Candide from IBM. Google used Systran for several years but switched to statistical translation method in October 2007. In 2005, Google improved its internal translation capabilities by using approximately 200 billion words from United Nations materials to train their system. Translation accuracy improved. Google Translate and similar statistical translation programs work by detecting patterns in hundreds of millions of documents that have previously been translated by humans and making intelligent guesses based on the findings. Generally, the more human translated documents available in a given language, the more likely it is that the translation will be of good quality. SMT's biggest downfall includes it being dependent upon huge amounts of parallel texts. Its problems with morphology rich languages, especially with translating into such languages, and its inability to correct singleton errors. So these are some of the challenges in SMT translation. Example based machine translation. This approach was proposed by Makoto Nagao in 1984 and is based on the idea of analogy or likeness. In this approach, the corpus that is used is one that contains texts that have already been translated. We already have example. Given a sentence that is to be translated, sentences from this corpus are selected that contain similar substantial components. The similar sentences are then used to translate the substantial components of the original sentence into the target language. and these phrases are put together to form a complete translation. Now this is very interesting. Hybrid machine translation. Hybrid machine translation leverages the strengths of statistical and rule-based translation methodologies. So hybrid machine translation carries the both strengths of both the methods we have talked so far. So several machine translation organizations claim a hybrid approach that uses both rules and statistics. The approaches differ in a number of ways, of course. Rules post-processed by statistics. Translations are performed using a rules-based engine, and statistics are then used in an attempt to adjust or correct the output from the rules engine. Statistics guided by rules. Rules are used to pre-process data in an attempt to better guide the statistical engine. And rules are also used to post-process the statistical output to perform functions such as normalization. This approach has a lot more power, flexibility and control when translating. It also provides extensive control over the way in which the content is processed during both the pre-translation, for example markup of content and non-transferable terms, and post-translation, for example post-translation corrections and adjustments. More recently, with the advent of neural machine translation, a new version of hybrid machine translation is emerging that combines the benefits of rules, statistical and neural machine translation. The approach, the hybrid machine translation, it allows benefiting from pre and post processing in a rule guided workflow, as well as benefiting from neural machine translation and statistical machine translation. The downside is the inherent complexity, which makes the approach suitable only for specific use cases. Neural machine translation. This is an approach to machine translation that uses an artificial neural network to predict the likelihood of a sequence of words, typically modeling entire sentences in a single integrated model. A deep learning based approach to machine translation, neural machine translation has made rapid progress in recent years, and Google has announced its translation services are now using this technology in preference to its previous statistical methods. And Microsoft team reached human parity on WMT 2017 in 2018, and this was a historical milestone. So Microsoft claimed they reached a human equal to human translation on WMT 2017. I mean, they claim this. Maybe that is true, but I still have to confirm it. Okay, assignment will be given on your easy class page. Thank you very much for your attention. Thank you.